Hi, kids. Hey, I'm going to do a little instructional video on scalars versus vectors, and then also how you go about naming a vector. So, how you draw and how you name a vector. So, a scalar, okay, is something that has magnitude only. Magnitude, just so you know, is how big something is. So that if I say, for example, that I am 5 feet 10 inches tall, the magnitude of my height is 5 feet 10 inches. Now, you'd want to include units when you say a scalar, because otherwise you sound like a crazy person. You know, how tall are you? Well, I'm 60 what? 60 inches, 60 centimeters. Hey, how long is this going to take? Well, 5. No, you have to include units. Okay, so a scalar is something that has magnitude only. A vector is something that has magnitude and direction. If you are a Despicable Me fan, you know that vector, as in the movie, is committing crime with magnitude and direction. Okay, so it's something that has that. So you are going to pause the video, and for each of these, you are going to put them in the appropriate thing. So is time, speed, velocity, and so on, are they a scalar or are they a vector? So pause it and figure it out. Yeah, did you pause it? Did you? Did you? All right, good. Time is a scalar. If you say, hey, 5 seconds, okay, that 5 seconds, you can't really say like 5 seconds and then add a direction. That doesn't make sense. So 5 seconds is a scalar. Okay, speed, how fast you are going, is also a scalar. I am going 5 meters per second. Okay, that's just telling you the magnitude of how fast you're going. And again, you got to include those units because otherwise you sound like a crazy person. How fast are you going? Oh, 3 what? Velocity is a vector. Okay, so velocity would be, for example, you could say 5 meters per second east. You could say 5 meters per second north. You could say plus 5 meters per second, where the plus is going to tell you the direction. Maybe that direction could be positive. Maybe if you say east is positive, west is negative, then plus 5 meters per second is telling you you're going east. Same thing if you were to have minus 5 meters per second. That minus sign would tell you the direction. Okay? Distance. Distance is how far you go. That's a scalar. Hey, I walked 5 meters. Okay? Displacement is a vector. Okay? Hey, I walked 5 meters east. Okay? Again, just like before, now it could be north or south or east or west, but you could have plus 5 meters where the plus is telling you what direction did you go. Maybe if you say plus is forward, then you went 5 meters forward. Maybe plus represents east, then you walked east. Okay, but that plus or minus again will tell you direction. Acceleration is going to be, and we'll talk more about this later on, but acceleration would be a vector. So acceleration is going to be 5 meters per second squared, and we'll talk about that later on. But an easy way to think of this would be, maybe it accelerates down, but if you think about the acceleration due to gravity, which way does the acceleration due to gravity point? Oh yeah, it points down. So like it has direction. Force is going to be a vector. Okay, we'll talk about this later. The unit for force is a Newton. Okay, so 5 newtons. Just so you know, 1 Newton is roughly a quarter pound. It's not exactly, but it's roughly a quarter pound. So next time you go to McDonald's, you can order a Newton burger, and they will know exactly what you're talking about. They'll probably be like, oh, would you like cheese on that Newton burger? But yes, 1 Newton is roughly a quarter pound. And then the last one is going to be energy, and this again will be something we'll talk about at a later date, but just so you have an idea, so the units for energy are going to be joules but 5 joules is going to be a scalar. Couple things just to make sure you guys understand is that, again, scalars have magnitude only. You got to include units. If you don't include units, you'll be wrong every single time. And then vectors are magnitude plus direction. All right, so how do we represent vectors? So vectors are represented by arrows. Now, whenever I tell my wife that I'm teaching vectors, she always gets annoyed, and she's always just like, well, no, it's just a bunch of effing arrows. And I have to be like, no, honey, vectors are not just a bunch of effing arrows. They are actually represented by arrows. So that, let's take, for example, 5 meters east. Okay, so if I wanted to represent that, I would draw an arrow that points east, and then I would label it. Hey, look, that arrow represents 5 meters east. Well, if I wanted to represent a vector that would be 10 meters west, you would draw an arrow that would be twice as long, and you would make your direction point to the west. So they are represented by arrows. Now, what gets a little bit confusing is what happens if that arrow points at a direction something like that, and that's where we're going to have to name the vector. So let's say I had maybe this, if this is 5 and this is 10, maybe this is 8 because that's how long it is. If I wanted to name that vector, it is not complete to say, well, this is 8 meters northeast. It's going northeast because which way northeast is it? Is it this way? Is it this way? Is it this way? Is it this way? So you would have to be more complete than that. So how do we name vectors and be more complete? Well, if I draw in my coordinate plane and then I find this angle, let's say that this angle, that looks like it could be about 30 degrees. So if I wanted to name this angle and be complete, so I know exactly where I'm going with this displacement vector, it would look something like this. It would be 8 meters at 30 degrees north of east. So here's what this is literally saying. I'm starting at east and I'm going 30 degrees north of it. Okay? But here's the part where it gets a little bit confusing. Now, this angle would be 60 degrees. So you could also say 8 meters at 60 degrees east of north, because I could start at north and go east of there. And if you wanted to be a real complete jerk, you could say, well, this is 90, so I could start at west and go 150 degrees north of west. And then if you wanted to be a complete turd, you could start down here and you could just keep going and going. Well, we're not going to do that. So that we all name the vector. And first of all, I want to say all of those different things that I said would be right. Okay, but it gets a little confusing. So I want to show you how we're going to name the vector all exactly the same way, so that, if you ask, any student in class, they would all say this vector is 8 meters at 30 degrees north of east. So when we're naming vectors, we're always going to have 3 parts. Okay, it's going to be the magnitude and the units, the angle, okay, and then it's always going to be north of, or actually I should say north or south of east or west. We're always going to do it that way. And then, so it's really easy if you just think of it this way. When you're naming vectors, you always want to pick the angle that touches the horizontal. So pick the angle that touches the horizontal. So let me give you a couple examples, and then you guys are going to practice a little bit. So here, let me give you a couple examples. So let's say I have, okay, there's my coordinate plane, And let's say that it's a force vector, so it's 10 newtons, because remember N for newtons. And let's say that this is, I don't know, 35 degrees. Okay, so if I wanted to name that one, well, if you look, this is the horizontal. Okay, 35 does not touch the horizontal. So if we're going to name it, so we'll all name it the same way, I want this angle. What is that angle? Well, that angle would be 65 degrees. So to name this vector, I would say 10 newtons at 65 degrees north of west. Okay. Let me do one more example, and then you guys are going to practice this a little bit. Let's say we had, I don't know, this here, where this was 40 degrees, and this time, let's say it's a velocity vector, so we're going 10 meters per second. Remember, if you're going 10 meters per second, that's going to be roughly double, so you're going roughly 20 miles per hour. So this velocity vector would be, if this is 40 degrees, would be 10 meters per second, magnitude units, at, I want my angle to be less than 90, so 40 is less than 90, but I want my angle to touch the horizontal, so there's my horizontal, so I want this angle, so that would be 50 degrees. So look, I am starting at east, and I'm going 50 degrees south of there, so then it would be south of east. All right, that should be good. Now you practice. Bye, kids!